So I don't have my tripod with me, so this is going to be a little shaky, but I just want to go through some of my slides from 2 days in class. I'm going to do them fairly quickly so you can pause it and look at it. But you should recognize that on this one, this is 7, and the other is 7 square root 2 when we work through that. And we should start recognizing this pattern that this always happens. And over here, we have 6 squared plus b squared equals 12 squared. And when we work through that, we get b square root of 108, which is basically 36 times 3, and therefore the simplified form is 6 root 3. And you should start recognizing that pattern as well. All right, so at the end of class, this is what you should have gotten out of all this, is anytime it's an isosceles right triangle, which is basically a 45, 45, 90 triangle, the two legs are the same. And this other one will always end up being that leg number times root 2. And the reason this works is whatever those numbers are, when you plug them into the Pythagorean theorem, you basically end up with 2 of them squared. And you can take the square root of that square and bring it out front, and you're left over with a root 2. So no matter what those numbers are, this pattern will always happen. And then what we worked on in class, basically stating that whatever this number is, hypotenuse is that number, root 2. And that makes sense because the root 2 is about 1.4, and it makes sense that the hypotenuse is about 1.5 times bigger than the leg. And this is just reminding you, this is what we do. And work our warm-up again before, just reminding you what that is. We work through the math. Once again, square root of 108 is 36 times 3, so square root of 36 is 6, and then that's root 3 left over. And the reason this works is this is half an equilateral triangle. So if that side is some number m, that side has to be 2m, because as an equilateral triangle, this whole thing, it's 2m and 2m and 2m. So that's m, that's 2m. And when we plug it in, m squared plus some I don't know squared equals 2m squared, I end up with 2m squared becoming 4m squared. And when I subtract the m squared, I'm actually left with 3m squared. And so square root of m squared is m, and I've got a root 3 underneath. Which basically means this side here is 1.7, which is roughly what the square root of 3 is, times longer than this one right here. So it's shorter than 2 times m, but longer than m. It's 1.7m, or m root 3. And then just a reminder that that pattern holds. All right, so we've got another warm-up here. Now in this case, we know these are both 7 square root of 2. It's a little odd because we're like, oh, I'm not used to seeing a square root of 2 there. I'm used to seeing it out here. But I know I just have to multiply this times square root of 2. So this just becomes a calculation problem. So it's 7 square root of 2 times square root of 2. That's 7 times square root of 4, or 7 times 2, which is 14. And this also kind of makes sense because this number down here is actually 7 times 1.4, which is roughly about 10, which makes sense that's about 14. All right, 7 square root of 6. Just trying to confuse you with numbers. So 7 square root of 6, both those have to be 7 square root of 6. This is some number. I don't know what it is, but it's some number. So to figure it out, I just multiply those two out. Now in this case, there's going to be a hidden square in here, because when I multiply square root of 6 times square root of 2, I get square root of 12, or square root of 2 times 2 times 3, because there's a 2 times 3 hidden in there. All right, so perfect square, can bring it out front. 7 times 2 times 3, I'm using these as times signs, even though they look like asterisks. So that's 14 root 3. 3 root 2. Now, for this one, it should be obvious to you that, oh, well, the pattern is I know these two have to be 3 for that to be 3 root 2. But technically what you're doing is dividing by square root of 2. When you divide by the square root of 2, it goes away, and you're just left with 3, because 3 to square root of 2 divided by square root 2 is 3. So what I really did there is this. I really just divided by square root of 2. And those cancel out, and that leaves 3. Okay, so I've got to switch this back. How do I turn this off arrow? Okay, and that's that. However, what if I start with 7? Well, same idea. I've got to divide by square root of 2. I'm dividing by 1.4. It's got to be a smaller number. I've got to divide by something to make it a smaller number. So I divide by square root of 2, which is roughly 1.4. And this is correct. It's just not written in a form that people like. We don't like having radicals underneath the division bar. So we're going to get rid of it. Would never be on a multiple choice test because you'd never find it. You'd be like, why is 7 over square root of 2 not there? So to change this looks like a lot, but it's not really. If I multiply by square root of 2 over square root of 2, this is just multiplying by 1. Square root of 2 times square root of 2 is 2, and square root of 2 in the top. Now I've got radical in the top, and this makes most math people happy. So anytime you end up with a radical in the bottom, the trick is if I multiply by that same radical over itself, that's a version of 1, it's not changing the value of the fraction, that ends up being a perfect square, it ends up at the bottom, and then the radical ends up in the top. And you will notice a pattern here that you don't necessarily always have to do it this way because there is a pattern going on here too. So this is the better answer for both sides here. And once again, if you need that as a note, you might want to write it down. Okay, 8. Once again, I'm going to divide. This becomes a calculation problem. It's 8 over root 2. I'm going to do that same trick, but something interesting is going to happen here. When I get 8 over 2 here when I do my little trick, but 8 divided by 2 will simplify to 4 root 2. So what does not look like 8 root 2 at all over here, 4 root 2, those are equivalent expressions. They are the same thing. If you put them in both in your calculator, you will get the same decimal number out. But they look slightly different. So, and you need to know how to convert like this. So this down here is 4 root 2. The better answer is 4 root 2. 3, that's 3 root 2. I don't know why I have that in there. It's too easy. 1 million and 1 million and 1 million square root 2. And it doesn't matter which way I turn it. Square root 2, square root 2. So what's this going to be? Still got to multiply. It's got to get bigger. So square root of 2 times square root of 2 is 2. Doesn't matter which way I turn it. 8 root 2. We know these divide by square root 2. They both end up being 8. And finally 5. We know we're going to divide by square root 2. And we've got to do that weird trick. 5 root 2 over 2. All right, same trick again. 3 root 2. Going to go through these pretty quickly. Pause it if you need to see it. All right, 30, 60, 90. Another review. If that's 8, that ends up being 4, which means this down here, when I go through the math, ends up 4 root 3. This pattern should be familiar. Whatever the short leg is, this is twice as much. This is bigger, but not twice as much. Remember, this is about 1.7. So it is bigger, but not twice as much. So if I start here, easy enough to work backwards, that's 7. And we can go through all the calculations. At this point, we hopefully maybe don't need to. It's 7 root 3. If this is 1, that's square root 3, because 1 times square root 3, and then that's 2. Easy enough. If this is 2 root 3, we're like, oh, I must have had a 2 over here. We're essentially dividing by square root of 3. So that's 2, and that's 4. This is 5. 5 halves. And then this is the way we typically write this. We put the radical and the numerator in the top over, numerator in the top and the denominator in the bottom. All right. If this is 5, so this is a calculation problem. What do I have to do to get back here? We know it has to be smaller. And we know when we're going in this direction, we're multiplying by square root of 3. So going backwards, we must divide by square root of 3. And then we have to do that same kind of trick before. We multiply by square root. I don't show it here, but basically what I'm doing is I am multiplying by square root of 3 over square root of 3, which is just 1. Square root of 3 times square root of 3 is square root of 9, or 3. And then this is what's left over in the top. Okay, so that's that same trick we saw before, just done much quicker. All right, and then over here, when I double this, I'm only doubling the numerator. I don't double the denominator. It's 10 root 3. So take a look at that. Same thing, same trick, except something interesting happens here. 6 root 3 becomes 6 root 3 over 3 when I multiply by root 3 over 3, which I'm not showing. But then the 6 and the 3 will cancel to 2 root 3. So that does not look very much like that, but they are equivalent. And then this is 4 root 3, because I've taken the 2 root 3 and I've doubled it. It's 4 root 3. It is not 2 root 6. You're not multiplying by square root of 2. You're multiplying by 2. Okay, I think that's it.